Welcome to this session. We have a problem for us to convert from binary form into duodecimal form. So what we do, we write this number without this zero. So just write point. So solution 0.306. Duodecimal means base is 12. So we'll be multiplying this number by 12 repeatedly, but then taking care of the whole number part, which will form our result. So the first thing, 0.306 times 12 gives us 3.672. So we have 3.672. And then the next multiplication, yes, you multiply by 12, but then you only multiply the decimal part, not the integer part. So the next answer will be given by 0.672 times 12, not 3.672. So 0.672 by 12 gives you 8.064. I remember these integer parts are the ones that are going to form our solution. So you try to test. The first digit here is 3, multiply by 12 raised power negative 1. And then 3 times 12 raised power negative 1, you get a quarter, which is 0.25, which is far away from 0.306. And then when you add the next digit times its place value, which is 12 raised power minus 2, 8 times 12 raised power minus 2, plus what we got previously, we have 0.3056, 0.5555. And then if you multiply the next, this one by 12, then you'll have 0.064 times 12. That will give us 0.768. And then when you multiply this by 12 again, you get 9.216. So this one here, this number here, you see 0.3055. If you round off this number to nearest 3 decimal places, it will give us the same number we have here. But because this number was to 3 decimal places, then we don't stop here. We have to have at least 3 decimal places. So that's why we are going to the next step. Assuming the number was given to 2 decimal places, we can stop at this point here. But because the original number is to 3 decimal places, that's why we have to go to another step, even if this number rounding off to 2 decimal places give us the same approximate 0.306. So next place value, it will be plus, this is 0 times 10, 12 raised power negative 3. So they will not change the value of that number. So then next digit here is 9. So when we add 9 times 12 raised power minus 3, then we'll have 3 times 12 raised power minus 1 plus 8 times 12 raised power minus 2 plus 9 times 12 raised power minus 3 minus 4. That will give us 0.30598 and then 595833. So you see, when you round off this one to 3 decimal place, it will be 0.306, which is the same as the value that you had. So this, we can stop at this point here and say, picking these whole number parts, then the number is given by 0.306 to base 10 is the same as 0.3809 to base 12. So that is how you obtain that answer. I advise that you check the beginning videos or lectures to understand how you write the decimal, you write the place values and the total values of every number in different number systems, so that you understand what I'm trying to do at this point here. And at this point, these first two were giving us approximately the same answer we have in the question, but we had to move to the next two steps because those would be only 2 decimal places, yet this number is to 3 decimal places. That's why we have to go to this step and this other step. And then next question, express 492.731 to base 10 into octal form. Now, when you are given a number, a decimal number, which has the whole number part not being 0, then it's always advisable to separate the two so that you get the answer differently and then bring them together. So 492.731 is the same as 492 plus 0.731. So you convert this one to base 8 differently, convert this one to base 8 differently, and then bring them together. So 492 using division algorithm will be, so 8 divides 492 61 times, then the remainder is 4, and then bring 61. Then 8 divides 61 7 number of times, and then the remainder is 5, and then bring 7. 8 divides 7 0 times, and then the remainder is 7. So because of this 0 quotient, then we stop and say 492 to base 10 is the same as 7, 5, 4 to base 10. So this is the integer part. Remember, for when you are dealing with integers, when we don't have decimal in the number, we pick these remainders in the reverse direction and we do division. But for decimal, we do multiplication and we pick the numbers, whole number parts, just from top to bottom. Now 0.731 to base 10. So we write it as 0.731 and then multiply by 8. When you multiply by 8, we get 8485. Next, we multiply by 8, but remember you're multiplying 0.848, excluding 5, and that will give us 6.784, and then multiply again by 8. But remember, we are multiplying 8 by 0.784, not 6.784. That will give us 272 and then 6. Next, you multiply by 8, and then you'll get, remember this 8 multiplies 0.272. The answer will be 6, and then 7, 1, then 2. Confirm that if you say 5 times 8 power negative 1 plus 6 times 8 power negative 2 plus 6 times 8 power negative 3 plus 2 times 8 power negative 4 is approximately 0.731. So therefore, this 0.731 to base 10 is the same as 5, 6, 6, and then 2 to base 8. Now bringing together 492.731 to base 10 will be the base 8 we have found here is 754. Remember, this is this base 8, this should be 8 here. So 754, and then 0.5662, then to base 8. So therefore, this is the final solution. So note that what you are doing to convert a decimal number into any of the bases from binary to either octal or binary or hexadecimal or to decimal, the first thing is that if we have a decimal, then take the decimal part and then you multiply by that new base you are getting, and then repeat this multiplication by only multiplying by the decimal part alone. And then as you do the multiplication, remember to take the total values of the digits from the start by the bases you are trying to change into to see whether the decimal you have agrees with the decimal given in the problem. Once you have reached that point, then you'll take all the whole number parts in order from top to bottom to be able to get the solution. And if we have a non-zero whole number part, then do it differently using the previous step of division algorithm, and then do the case for decimal part differently, and then join the two answers to be able to get the correct solution. I advise that you check the previous videos so that you understand how this process is working on these two problems we have solved in this session. Thank you.